On this one, it's actually not going to be a y, it's going to be an x equals a sine of theta. And just working ahead, I could already see that I'm going to end up using x squared, which is going to be a squared sine of squared theta. And this is going to be the substitution needed in order to further simplify this. Since b over a is just a constant, I'm gonna leave that out until I'm finished with the actual solving of this problem. You're gonna have a squared minus the x squared that we just figured out, a squared sine squared theta. And from here, you can take out one of the a squared to make it look like this. And since one of the identities that I think it was a trig identity that says 1 minus sine squared theta equals cosine squared theta, we can switch this 1 minus sine squared theta to turn to be a cosine squared theta. And at this point, this simplifies to a cosine theta. This is what y is. Now moving on to finding the area of the ellipse. The area is going to be 4 times the integral of 0 to a b over a squared minus x squared dx. But since we already know what this is as a cosine theta, we're gonna switch that out. And now we're gonna have a equals 4 times b over a cosine theta, and the dx is going to be the derivative of a sine over here, which is a cosine theta d theta. A cosine theta d theta. Since b over a is a constant, I can take that out on the outside. And this one I just simplify it since they're both multiplying to each other. Once again, the a squared is a constant, so I can take that out for b a squared over a 0 a cosine squared theta d theta. And I can take this one and simplify it even more. Cosine squared theta d theta. Now I'm actually gonna have to substitute the 0 and the a on the x on this one, x equals a sine theta, to find to change the limits of integration. So at x equals 0 equals a sine theta. Sine theta is actually going to be 0. So a equals going to be 0, and at 0 equals, now at a equals a sine theta. a over a equals sine theta is 1 equals sine of theta, and sine of theta is 1 at pi over 2. Oops, this one's wrong. So now we're gonna have 4BA from, we're gonna switch out the 0. It's 0 is gonna say 0. The A is gonna turn to pi half cosine squared theta d theta. And using one of the half angle identities, we could change out this cosine squared theta to to 1/2 plus cosine 2 theta d theta. I can take out the 1/2 since it's a constant, and that's going to change this to 2BA from 0 to pi over 2. 1 plus cosine 2 theta d theta. From here, it's just a simple integration of this function. It's going to be 2BA, and since 1 is just going to be theta, plus sine of 2 theta over 2, and that's going to be from pi half to 0. BA from pi halves and sine to pi over 2 equals to minus 0. I know that if I substitute the zeros on this one, it's going to be 0 plus sine of 0 is 0. On this one, coming back to this one, it's going to be the 2's for the sines of 2 times pi over 2 is going to cancel out. You're going to be left with sine of pi. Sine of pi is 0. Divided by 2 is also 0. So now you're going to have you're going to be left with 2BA times pi over 2, which is B and A times pi. This is the area of an ellipse. If B equals A and B equals A and A equals R, then you're actually going to have pi r squared, which is the area of the circle, and that would be if these two right here are equivalent. That's how you figure out the area of an ellipse.